Page 179 is the gift that keeps on giving. We are up to question 3. It goes with this graph up here. And I had to go ahead and put that on a different page just to have enough space. So let's take a look at this one. Iris flew 2 separate airlines to reach her destination. With the first airline, she had to pay $26 to check her bag, plus $3 for every pound that her bag was over the weight limit. On the second flight, she had to pay $5 a pound that her bag was over the weight limit, in addition to the checked bag fee of $22. The 2 airlines have the same weight limit for checked luggage, and Iris's luggage fees were the same for both flights. Those last 2 sentences are just standardizing the problem. They are taking out every other variable except the overage fee and the flat fee. So let's take a look at the first airline. We could say that the cost of her flight, or the cost of her luggage, would be the overage charge plus the flat fee. And this is the yellow scenario. So we have the overage charge is $3 a pound, plus the flat fee for the first one was $26, and that is the total cost. So this is in slope-intercept form. Actually, I'm going to instead of using the word cost, I'm just going to use the letter C. So the cost is $3 a pound plus $26 flat fee. Then I have that same situation for the second airline. We have an overage fee if your bags are too heavy, plus a flat fee. So in the green story, the cost is going to be $5 a pound, but your flat fee is lower. It's only $22. So here are the 2 equations in this system. They're in slope-intercept form. I know I have to graph in a second, so I'm going to go ahead and put this in terms we can understand. There's slope. Well, slope is 3/1, and then the y-intercept is at 0.26. Okay, and then in this formula, slope is 5/1, and the y-intercept is at 0.22. So now we are ready to graph. It says to graph the 2 equations, the 2 that we just wrote, to find out how many pounds over the weight limit Iris's bag was. So 26, the y-intercept is more than the graph has on it. Okay, let's just do a coordinate plane. We'll not use this graph because it doesn't go far enough. So let's set a plane down here, and we'll just use this one. Not sure, unless I'm missing something, I'm not sure what that's about. But here we go. This is a good opportunity to review independent and dependent and all that good stuff. So here is the x-axis. Need to get it straight or the graph won't be straight. And then here's the y-axis. So on the independent axis, what is the thing that Iris can control? Iris can control the weight of the bag in pounds. When I fly, I pack everything I have. I don't know why I think I have to take everything. So you decide if you have 1 pound, 2 pounds, 3 pounds, 4 pounds, 5 pounds, 6 pounds, all that. So 1, 2, 3, 4, 5, 6 to infinity. You can make it as heavy as you want it to be. What you cannot control, what depends on your decision, is the cost. So the cost in dollars is the dependent variable. And I need it to go to at least 26. It's going to have to go higher than that for me to show you what I need to. So I'm going to start, if you spend zero, or if you have 0 pounds, you pay $0 for the luggage. But now there is a catch here. So we have 2, 4, 6, 8, 10. $10, $12, $14, $16, $18, $20, $22, $24, $26. Now, I'm going to have to go higher, but for the moment, let's stop here. So, let me bring these two equations back down here. Let me just do it this way. We have C equals 3P plus 26. And then we have C equals 5P plus 22. So I'm going to move these down here. I had to be able to see them to write them. So let's bring them right here. For this one, we said the slope is 3 over 1. Rise over run. And the y-intercept is 0.26. For this one, we said the slope is 5 over 1. And the y-intercept is 0.22. Okay, now think through this with me. Let me just write it down. I said a minute ago, if you don't have any pounds of luggage, you don't have any dollars. But that's not exactly true. Remember that the 3P is for anything over what you're allowed to have. So if you have 0 pounds, you don't pay any overage, but you still have to pay that flat fee. So at 0 pounds, the cost is 26. That's why I can tell you with certainty that this intercept is true. You have no weight, but you still have to pay the handling fee. So let's go ahead and plot that particular point on the graph. 0 pounds, but you still have to pay $26. Okay, from there, slope on this one, remember, is 3 to 1. So let's plot our slope. We are going to rise 3 and run 1, rise 3 and run 1, and there I'm going to go ahead and put my point down so that I can draw a graph. So the equation for the first airline is something like this. Okay, that's that 3 to 1 slope. I rise 3 and I run 1. That's my 3 to 1 slope. So if I don't bring any luggage at all, I think I would still owe that flat fee, even though I'm not using the luggage. All right, let's go ahead and plot our other point where the intercept is 0.22. So you spend, or you have no pounds, but you still owe the flat fee of $22. And then this one's going to climb 5 and run 1. So up 5 boxes, 1, 2, 3, 4, 5, and run 1. Now look at what happens right here. That graph is going to intersect the other graph. Here is the, hang with me a minute, it looks like that, something like that. This is the green slope. You're climbing 5 and you're running 1, and it intersects the red slope right at that point. And it's that point that I'm so interested in. What is that point in terms of an actual coordinate? Because that's the solution to this system. Well, here's 28. Here's 30. And that is 32. It is at 132. That gives me the answer to the next question. I don't like this problem. It's a good problem, but it's not. What was Iris's checked luggage fee for each flight? The cost was, remember this is the cost, and this is the pound. So for each flight, she had to pay $32 for 1 pound over. Her bag was 1 pound too heavy, and for each flight, that cost her $32. I know that because they intersect at 132. Goodness, what a problem.